In this video, we're going to do a quick overview of the classification of matter. So in chemistry, we study matter, which is anything that has a mass and anything that has a volume, anything that takes up space, in other words. And when we study matter, you can classify it into two main categories. You can classify it into pure substances, and the other main category is mixtures. So we have matter that can be either a mixture or a pure substance. A pure substance is when you're dealing with one type of particle. And then in a mixture, you have more than one type of particle. More than one type of particle. In science, pure substances can be further divided into two other categories. You can be an element, or you can be a compound. So element would be anything found on the periodic table. For example, you could be sodium. You could be lithium. You could be helium. So anything with just one uppercase letter. An element, on the other hand, or a compound, on the other hand, is two or more different elements chemically combined. So two or more different elements combined, chemically combined, we say, meaning they become one. Even though there's different elements in there, you might think, oh, isn't that a mixture? No, they've actually connected together chemically, so they've become one type of particle. For example, this here is H2O. This is the compound water. There's two hydrogens and one oxygen connected together. When I say they're connected together, they're actually connected by these little bonds here, these electrons connecting together. So that's a compound. Or NaCl, that's a compound. Or KCl, that's a compound. So whenever you see a compound, whenever you see an element, those are considered pure substances. And just to show you a visual of that, so suppose we have a box here. I'm going to draw a box that only contains one type of particle. We'll say it only contains sodium. Let's just say that. So my little circles here represent sodium. These are all sodium atoms. So this box is a pure box of element sodium. Let's do a box over here. I'm going to do sodium chloride. I'll represent it like this, a colored in circle and a circle that's not colored in. So that's sodium chloride there, NaCl. And so notice that I'm going to make a box with only sodium chloride. It's only one particle type. This thing over here is the particle. So this is a pure box of sodium chloride. So compounds are considered to be pure substances. One more thing to clarify as well, things like this, like H2, O2, F2, even though there's two atoms in each of these, they're not considered compounds. They're still considered elements because a compound has to have two or more different elements in them. So this H2, O2, F2, they're still elements. We just give them a special name. We call them molecular elements because, well, they're molecules or two or more atoms connected together, but they're still elements because they're not two different elements, so they're not considered compounds. And then we don't use this very often, but if you just have the atom by itself, we call that a monoatomic element. That means one atom. Mono means one. Okay, but regardless, elements are still pure substances. Compounds are also pure substances. Mixtures, they can also be further divided into different categories. You can have heterogeneous mixtures. So you can have heterogeneous mixtures, and then you can also have homogeneous mixtures. So heterogeneous, and then homogeneous. Heterogeneous mixtures, you can see all the different particles there. You can see the different particles that are part of it. So if you think of it like a chocolate chip cookie, you can see the chocolate chunks that are there. And then you can see all the other parts as well. You can think of it like a salad where you can see you can see the carrots, you can see the lettuce, you can see the tomato. So you can see all the different parts of the mixture. Whereas a homogeneous mixture, you cannot see the different parts. It looks like it's only one particle type, but it's not. There's actually other particles in there that you just can't see. It looks like we say a uniform composition. It's kind of the same. It's the same throughout. So uniform composition. So if you ever seen salt dissolved in water, when you dissolve salt in water, you have a mixture there, but it looks like just pure water because you can't see the salt, but it's actually a mixture. So salt dissolved in water. I'm going to write NaCl dissolved in water. That's an example of a homogeneous mixture that we sometimes call a solution as well. A solution is when you can dissolve something in something else, and then they dissolve perfectly into each other, and you can't see the different parts. So if I were to draw this as a box over here to show you the difference between mixture and pure substance, I'm going to draw some NaCl like I did over here, this same representation. So there's NaCl in this box, NaCl, NaCl, NaCl. And then I'm also going to add some H2O. And H2O will just have drawn like this, a big circle like that, and then two little ones like this. And so notice that this box has compounds. Yes, individually, the compound is a pure substance, but here I have a mixture of compounds. So here I have a mixture of compounds. If I were to zoom in and I could see the particles of the homogeneous solution, I would see it. There's some water in there and some salt in there. So I have a mixture of compounds, so it's no longer a pure substance. Also, sometimes we mix metals together, and they look like it's just one metal, like, for example, brass. It looks like one metal. It's a solution of solids. But so that means it's a mixture. They're not chemically combined, but they're a mixture. So we have some Cu plus some zinc. That's what brass is. The brass is not an element. It's a mixture of copper and zinc, and they're not together as a compound. They're separate. They're their own thing. So let's say this is copper here. Here's some copper, and then this one will represent zinc. So we have a mixture of elements here. Even though these are pure on their own, in this box you have a mix of elements. You have your zinc, you have your copper. In this box you have your H2O, and you have your NaCl. So overall, we saw that matter can be classified into two categories, pure substances and mixtures. If you're a pure substance, you can be an element which only has one uppercase letter, and that element can be a monoatomic one, or a molecular element with two of the same connected together. And then we saw you could be a compound where you have two or more different elements chemically combined. So it's still considered one particle type. Like if you look in this box, it's only NaCl, and that's it. There's no other particle types there. Everything's the same. And it's a nice way to visualize mixture, the mixtures versus pure substances. So again, pure substance is one type of particle. Mixture is more than one type of particle. So there's different particles available. And if you can see the different particles or the different parts of the mixture, we call that a heterogeneous mixture, meaning different, like a chocolate chip cookie or a salad. And if you can't see the different parts, if it looks like it's pure, but we know it's not deep down, then we say it's a homogeneous mixture. Homo meaning the same, looks uniform throughout. So salt water solution has salt and water in there. So there's a mixture of compounds, some water and some salt. And then brass is an example of a solid solution. You have some copper and some zinc in there, but they're not chemically combined. That's why they're not considered a compound like this. To be chemically combined, they need to be joined together with those electrons like I drew with the salt and the water over here, for example. So this is salt, chemically combined there. And same thing here, the salt and the water are not chemically combined. The water is still separate, and the water and the salt are still separated from each other. So that's why that's considered a mixture.